All right, continuing on with geometric sequences as exponential functions. So in the previous video, we talked about sequences of numbers and figuring out the common ratio, or what we're multiplying by over and over to get each next number in the sequence, right? All right, well, that's great. So if you have the first 3 or 4, numbers in a sequence, like let's say it's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2, okay, wonderful. So I have the first 5 terms in my sequence, right? Well, what if my question was, what's the 56th term in this sequence? Am I actually going to go through 56 times and multiply by 2 over and over? I mean, I certainly could. It's easy enough, but it's going to take forever. There's actually a shortcut. So when you're asking for a number way down the line in a sequence, you can use this formula, shortcut right here. This is your geometric sequence formula, okay? So it's a sub n equals a sub 1 times r to the n minus 1 power. What? What are we, what? What? Okay, first thing is we need to understand what a sub n and n represent, okay? So if I have a sequence of numbers here, here's my numbers, each number holds a spot in line, right? So 2 is my first number in line. 4 is my second number in line. 8 is my third number in line. 16 is my fourth number. 32 is my fifth number. So the place in line each number is, that's n. That's the place. So if I said, what's the third number in the sequence? When n is 3, the third number is 8. These numbers, these values are a sub n. A sub n. So the third number in the sequence would be a with a little 3 under it, right? This would be a with a little 1. This would be a with a little 2. This would be a with a little 3. A with a little 4. A with a little 5. So the place it is in line is just n, right? What's the fourth number in line? 16. The number that sits in the fourth place in line is a to the whatever. So if I'm talking about the fourth place in line, n is 4, and then that value, a sub 4, is the actual number, is 16. A sub 4 equals 16, okay? Some people can't wrap their minds around that. I drew a little visual on the back of my paper to kind of maybe help. It's probably saying the exact same thing. If you had a line of people, right? We've got Bob, Phil, Pam, Ted, Janice, and John. They're old. If we have all these people here in line, they're in an order, right? The first person in line is Bob. He got there early. He's an early bird. Phil is the second person in line. Pam is the third. Ted is the fourth. So the order they're in line is n. That's their number. Who's the third person in line? When n is 3, who's the person? Pam. Pam is a sub 3, right? So Bob is a sub 1. Phil is a sub 2. Pam is a sub 3. Ted is a sub 4. Janice, a sub 5. John, a sub 6. Does that kind of make sense? So the place it holds in line is one thing. What's in that place is a whole separate thing. So a to the whatever, the little whatever tells you what place it is in line, but then that whole entire value is what's there. So when n is 4, what's a to a sub 4? In this case, Ted. Ted is a sub 4. When n is 2, what's a sub 2? Here's the second place in line, so a sub 2 is Phil. When n is 6, what's a sub 6? The sixth person in line is John, so John is a sub 6. I hope that's making sense. I know that's kind of goofy. All right, so going back here. So for our formula, in general, whatever number term we're looking at, that's going to go here. So the number in line is the first number in the sequence, whatever that value is, the first one in the sequence, times the common ratio to the n minus 1 power. So if I'm looking for the fourth number in the sequence, I want to know what that fourth number is. Is it Pam, Janice, Ted, right? What is it? I'm going to use the first number in the sequence times the common ratio to the 4 minus 1 power. N is what place it is in line. A sub n is what the actual value there is. All right, so let's do a couple of these. here we have a geometric sequence, 5, 20, 80, 320, right? So I'm going to use my little formula here. A sub n equals a1 times r to the n minus 1. And it asks me to find the common ratio. I did find the common ratio. Is it asking me for a certain one, right? It was for the nth term. Oh, this is in general, sorry. So if it asks you to find the nth term here, this is like if it said find the fifth term, then you would plug a 5 in for n, right? If it says find the nth term, you don't know what to plug in for n. You're just coming up with a general formula. So when it asks you this type of question, you won't have a one number answer. You'll have a formula. When it actually tells you solve for the 16th term, then you'll get a one number answer. Not a one digit answer, just a one, like it could be 327. That's one number, right? But here, it's not asking for anything specific. It's just asking for a general formula. So we plug in what we have. In this case, we know that the first number in the sequence is 5, because that's the first number in the sequence. And we know the common ratio is, we're multiplying by 4 over and over, right? So the common ratio is 4. So I can plug the first number in, that's 5, and r, I know, is 4. So I get 5 times 4 to the n minus 1 power. And I can't simplify it more than that. I can't multiply 5 times 4 because first I have to raise 4 to this exponent, and I don't know what the exponent is. So it would just stay like this. This is the formula for finding the nth term. I still use this. I just can't plug anything in for n. Okay, let's do an actual problem. Here, find the 7th term of the sequence. Find the 7th term of the sequence. Because we're looking for the 7th term, n equals 7. And what is, oh, I'm still using the same sequence, sorry. I'm looking for the 7th term in the sequence. So I know this is my A1. A1 equals 320. Oh, what? The first term of the sequence is not 320. What? The first term of the sequence is 5. I don't know. This is wrong. We'll just start with this. So here's our sequence. 5, 20, 80, 320. 5, 20, 80, 320. There's our sequence, okay? First number in the sequence, A1. Common ratio is 4. I'm multiplying by 4 over and over. And I'm looking for the 7th term of my sequence. So when I use my formula, I'm going to use A sub n equals A sub 1 times r to the n minus 1. A sub 7, that's the number I'm looking for. I know it's going to be the 7th number in the sequence, but what is that number? That's what I'm trying to figure out. So the first term, which is 5, times the common ratio to the n minus 1 power. I'm looking for the 7th term in the sequence, the 7th number, so 7 goes in for n. So now I can actually simplify this, right? 7 minus 1 is 6, so I'll get 5 times 4 to the 6th power. 4 to the 6th power, 4, y to the x, 6 equals 4,096. So 5 times 4,096, and then I multiply that by 5, and I get 20,480. That is the 7th term in my sequence. If all I'm doing is multiplying by 4 over and over, think about it. That's the 7th term in my sequence. I already know the first 4, so I just need, I just need to multiply by 2 a few more times. So the 5th number in the sequence, I'm sorry, not by 2, by 4. 5th number in the sequence is 1280. The 6th number in the sequence is 5120. And the 6th number in the sequence, 2480. Oh, that's not the 7th. Hang on. 1, 2, 3. 4th number in the sequence is 320. 5th number, 6th number. Okay, there we go. That's the 6th number in the sequence. Oh, I'm multiplying by 2. Just kidding. 320 is the fourth number, times 4, that's the fifth number. That's the fifth number. That's the sixth number. That's the seventh number. The seventh number in our sequence is 20,480, which is what I got over here when I plugged everything into my formula. So you're gonna get a whole bunch of practice right here doing that, okay? Let me back out just a little bit. For every single one of these, we're using a sub n equals a sub 1 times r to the n minus 1. All right, write an equation for the nth term of the geometric sequence. Boom, boom, boom. And then find the 11th term. So first I want to write a general formula. Then I'm going to plug in 11 for n and solve. So a(n) equals a1, which is -2, times the common ratio. Looks like I'm multiplying by -5 over and over. -5 to the n minus 1 power. Okay, so that's my formula for the nth term. And then I need to find the 11th term. So I'm going to plug in 11 into this for n. A sub 11 equals -2 times -5 to the 11 minus 1 power. 11 minus 1 is 10. -5 to the 10th power is this big old number. Huge. And then I have to multiply that by -2. So times -2. So I get -19531250. -19531250. 1250. And if you're asking yourself, like, is that right? I mean, we're finding the 11th term in the sequence, and we get from one to the other by multiplying by 5. Yes, the negative sign switches out every other number. Is going to be either positive or negative, but we're still multiplying by 5. So 50 times 5 is 250. 250 times 5 is 1250. 1250 times 5 is over 6,000. 6,000 times 5 is over 30,000, right? So it goes up in a hurry because we're multiplying. So this makes sense. This should be your answer for number 1. I'll do these in different colors so they don't run together. All right, write an equation for the nth term. Here's the geometric sequence. So I'm going to have a sub n equals first number in the sequence, 512 times common ratio. To get the common ratio, I'm going to take the second number and divide by the first. 128 divided by 512 gives me 0.25, which is 1/4. So my common ratio is 1/4 raised to the n minus 1 power. Here's my formula for the nth term of the sequence. Then it asked me to find the 6th term. So I'm going to plug a 6 in. A sub 6 equals 512 times 1/4 to the 6 minus 1 power. Excuse me, that's 1/4 to the 5th power. 1 divided by 4. Ooh, that's a really tiny decimal. We could actually change that to a fraction. 1/4 to the 5th power means 1/4 times 1/4 times 1/4. It's 1/4 times 1/4. Okay. So on the top, I'm going to get a 1. 1 times 1 times 1 times 1 times 1 is 1. 4 times 4 is 16. Oops. Times 4 is 64. Times 4 is 256. Times 4 is 1024. So it's going to be 1 over 1024. 1/4 to the 5th power equals 1 over 1024. So this number right here is what I'm working with. Excuse me. 1 over 1024, and I'm going to multiply that by 512. So I'm going to get 512 over 1024, which is equal to 1/2. 1/2. So that's the 6th term in my sequence is 1/2. Because I had this, which is 1/1024, times 512. So when I multiply straight across, I get 512/1024. 512 divided by 1024 is 0.5 or 1/2. So the 6th term in my sequence is 1/2. I'm going to skip these two to give myself room and go down to number 5, just so I have room. All right, for the nth term, so AN equals A1 times R. To get from 100 to 80, I'm going to divide 80 by 100, which is equal to 4/5. So our common ratio is 4/5 to the n minus 1 power. There's my formula for the nth term, because I don't know n, but I do know the first term in my sequence, and I know the common ratio. I can figure it out. Okay, so then it asked me to find the 7th term for this sequence. So A sub 7 equals 100 times 4/5 to the 7 minus 1 power, which is 6. Okay, so I'm going to multiply 4/5 out 6 times and then multiply that by 100. Oops. 4/5. Excuse me. All right, so 4 times 4 is 16, 5 times 5 is 25, so that becomes 16/25. 16 times 4 is 64, over 125 times 5 is 125, so this becomes 64/125. This times 4/5 is 64 times 4, 256. 125 times 5 is 625, I believe. So, so I've done that. Now it's times this 4/5. 256 times 4 is 1024. 625, oops, times 5, 3125, times one more 4/5, 15,625, and 1024 times 4, 4096. So this is the ratio I get before I multiply times 100. So I want to go ahead and change that to a decimal. So I'm going to divide it. 4096 divided by 15,625 is that times 100 is 26.2144. 26.2144. And does it tell me what to round to? Nope, just says find the 7th term. So that number is 26.2144. That's the 7th term in my sequence. If I just keep dividing over and over, I'll get down to this number. All right, I'm going to stop there. They're all the same. You guys can see they're all the same. Actually, we'll do one more with fractions. Okay, so for the one right below it here, number 6, I am going to cover this up. It's the last one I'm doing, so I want to give myself room. I'm looking at this sequence of fractions right here. So we've got 2/5, 1/10, 1/40. These are our 3 numbers. So first thing I want to do is find the common ratio. So what did I multiply this by to get this? Well, this looks funny, right? So could this have been simplified? What if I double this? What if I have 2/5 and then I just double all of this and I get 2/20? It's still the same fraction, it's just I just made it look different, right? So what did I multiply this by to get this? Well, the top didn't change, so I multiplied it by 1. What did I multiply the bottom by? 4. So could my common ratio be 1/4? This times 1/4 is this, which I simplified to this. This times 1/4 is this. Does that make sense? Yeah, 1 times 1 is 1. 10 times 4 is 40. That makes sense. So my common ratio is 1/4. So R equals 1/4. And instead of writing an equation for the nth term this time and then just plugging in a number, I'm going to write an equation for the 6th term. Okay, so A sub 6 equals the first number in the sequence, 2/5, times the common ratio to the 6 minus 1 power. So here's my formula. 6 minus 1 is 5. So if I multiply 1/4 out 5 times, what do I get? 1/4 times 1/4. There's 2 of them. That gives me 1/16. I'm going to do a third one. 1/64. A fourth one. See, I use 1, 2, 3, 4. 64 times 4. 256. And then I got one more because I had to raise it to the 5th power. Remember, 6 minus 1 is 5. So 1/4 to the 5th power. I've multiplied it out 4 times already to get this. Now I got to multiply it by one more. 1/4. 1/1024. Okay, so this is equal to 1/1024. 2/5 times 1/1024 equals 2 over, what's 5 times 1024? 5120. And can I simplify that? Can I divide the top and the bottom by 2? Absolutely. 2560. So this would be the 6th term in my sequence of fractions here. If they're in fractions, I don't want to give my answer as a decimal. I want to keep it as a fraction. So I hope that was a good example showing you how to do that. All right, so I know it seems tricky because the numbers are weird and plugging in, whatever. As long as you understand, you use this formula, you understand where to plug in the n, the r, and the a sub n, then you'll do just fine. Let me know if you have questions.